All right, this is day 2 of quadrilaterals. We're going to spend one more day on quadrilaterals, and then the test is Thursday, and then you have Friday off. So today we're going to talk about a special kind of quadrilateral called a parallelogram. Before we do that, though, let's figure out how we can answer these questions. Now, as you remember, this is a four-sided shape. So you would take 180. There we go. Let me erase this. 180 times 4 minus 2, which is really 180 times 2, and that's 360. So I know that all these angles are going to add up to 360. These have an invisible 1, so that's 2, 4, 5, 6. So 6h equals 360. When I divide, h is going to give me 60. Then I got to plug it in. And what you'll notice is that 60 times 2, this is 120, 120. And this one's 60, and this one's 60 as well. Erase this 0. Now there's some cool observations you're going to make today about angles that are right next to each other like this. On the same side, we call them supplementary. Same side interior angles when you have parallel lines. All right, over here for number 16, once again, you're going to count the sides. There's 1, 2, 3, 4, 5. So the number of total degrees of this polygon is going to be 180 times 5 minus 2. So it's actually 180 times 3, which is 540. And now you're just going to add up all the sides. So this plus this plus this plus this, subtract it from 540, and you end up with x being 103 degrees. All right, for number 17, once again, you're going to count up the sides. 1, 2, 3, 4, 5, 6, 7. So it's 180 times 7 minus 2. So 180 times 5. So all the angles are going to add up to 900 degrees. And once again, you just add what you know. Type it in your calculator. And this time you're going to subtract it from 900. And I didn't work it out, but whatever you get in your calculator is what the answer is. All right, let's do some exploration of parallelograms. For this, you're going to need a protractor to measure your angles. So, this T is a mistake. Let's see if I can move it. I cannot. So this T should be. Okay, so the first thing we're going to explore is what you notice about the angles. So if you measure this angle here, angle A, you should get 140 degrees or something around there. And then a measure of angle M is 40 degrees. So a couple things I want you to notice. If you add these two angles up, again, parallelogram, you should see the word parallel. These sides are parallel, and these sides are parallel. So if you think about parallel lines cut by a transversal, these angles here are same side interior angles, and so they're going to be supplementary. And so if you add them up, they should equal to 180 degrees. All right, and another thing you should notice about this is that this angle over here is also 140 degrees, and this angle over here is 40 degrees. And again, the reason for that is parallel lines cut by a transversal. If we made the transversal line a diagonal, you would see that you have alternate interior angles as well. So what do parallel lines have to do with parallelograms? Well, the opposite sides are parallel, as I've marked here. And that gives some interesting angle relationships. The angles across from each other, and I apologize, this should just have one marking here. And next to each other, they're supplementary. There's one more thing I wanted to show you. There are also cool relationships with diagonals. So if you draw a diagonal here, I'm going to do my best to keep it straight. Not too terrible. And a diagonal here. Okay. This is an intersection point. We'll call this D. And D is actually a midpoint. So it's going to cut, if you measured this, this and this are congruent, and this side and this side are congruent. So D is in the middle of both of the things. Also, what you should notice is that this side here is congruent to this side here, and this side here is congruent to this side here. So we've now discovered special relationships in the angles and special relationships in the sides. So, for example, if I said that this segment right here was 2, you would know this segment is 2 as well. If I said this side was 5.3, well then you know that this side is 5.3 as well. Some special vocabulary is that a quadrilateral is a parallelogram if both pairs of opposite sides are parallel. Okay, hence the word parallelogram. Both sides have to be parallel. And again, how you can mark it is with these arrows, or sometimes you'll see just a marking like this. Okay, so this is a special type of quadrilateral. It is a 4-sided figure in which the opposite sides are parallel. All right, so let's talk about some theorems. We've already discovered the theorems, now we're just going to put a name to them. So if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. So what does this mean? That means that this side is congruent to this side, and this side is congruent to this side. So for this parallelogram, I want to solve for x and for y. So I'm looking at this. The easiest thing to do is to do the sides in red first to figure out what x is. So if I know that they are congruent, I got to think to myself, how am I going to set up this equation? Well, they're congruent to each other. So it's going to be 3x minus 5 equals 2x plus 1. And then I subtract 2 x's out of the 3. And I'm going to add 5 to the 1. So that's 1x equals 6. So now that I know x is 6, I can plug it in right here. So 6 plus 2 equals 8. And because I know that this side is 8, I now know that y is also going to be 8. All right, so you kind of have to use deductive reasoning to figure out how you can solve for both variables. Now we know that both pairs of opposite sides are parallel and congruent. So now we want to know about opposite angles. Well, we discovered that opposite angles are also congruent. So let's take a look at this. It says the measure of angle y, which is right here, is 49 degrees. The measure of angle z is 131, and the measure of angle w is 49 degrees. Now, this one's 131, so now I know that this one also has to be 131 degrees. So if they want to know the measure of x, it is 131 degrees. Now, if they didn't give me this information, I could easily figure it out. I could just take 180 minus 49, and you get 131. Because of same-side interior angles, these angles are always going to add up to 180 degrees. Again, everything in geometry is real basic. You just got to think, do they add up to 180? Do they add up to 360? Are they equal to each other? The hard part is actually setting up the equation. Okay. And remembering all these rules. If a quadrilateral, then all pairs of consecutive angles are supplementary. And so this is what we just talked about. They add up to 180 degrees. Consecutive is another way to say same side interior. So, what I know then is that angle E and angle H are going to add to 180. And then I know that F and G are going to add to 180. Okay? So let's solve for y first. So I'm going to do 3y minus 2 plus y plus 10 equals 180. 4y plus 8 equals 180. subtract out that 8, and divide by 4. So 4y equals 172, which means y equals 43. Now you can do the same thing to solve for x. So that's going to be 4x plus 12x. So I'm just going to do that right now. That's 16x. And then you've got 13 plus 7 right here. 13 plus 7, so that's 20. And that's going to equal 180. So subtract out your 180, your 20. So x is 10. And now there's another theorem. So now we've learned a theorem about the side lengths, we've learned a theorem about the angles, and now we're going to talk about the diagonals. Sorry, my board's kind of acting funky right now. So what did I tell you about the angles, the diagonals? Is that this part right here is congruent to this part right here. And this part, the other two parts are congruent. So if we're going to solve for y, we're just going to simply say y minus 1 equals 2y minus 7. Put your line down the middle if you want. I'm going to subtract y from here, and I'm going to add 7 here because it's negative, so I'm going to add it. So this is 6 equals y. It's 2y minus 1y is y. Okay, now we can do the same thing for x. This part right here is congruent to this part right here. So I'm going to do 2x equals 4. Well, this is easy. Divide by 2, so x just equals 2. Always go back to the question and make sure that you're answering it. In this case, it just said to solve for x and y. Sometimes I'll actually ask you to plug it back in and figure out what the side length is. So for example, if I wanted this whole length right here, I know this part's 4 and this part's 4, so dB actually equals 8. All right, and everybody's favorite. Here's an example of what a proof would look like if you wanted to prove that AB is congruent to CD and BC is congruent to DA, making this a quadrilateral, okay? And so a couple things we can say is that, and a special type of quadrilateral parallelogram, okay? Well, one thing is we know it's giving us that it is a parallelogram, okay? So we know that this side is parallel to this side is parallel to this side, which makes this and this alternate interior angles, and this one alternate interior angles, and then everybody remembers the reflexive property in the middle. So we know that these two triangles are congruent using ASA. So now we can go back and say these sides are all congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. So we're kind of putting it all together in this proof. You might want to reference this because most parallelograms, if they're given a diagonal, will use these reasons for their proofs. All right. So let's go ahead and try one. Go ahead and work with a partner and see if you can do a 2-column proof, you can do a paragraph proof, whatever you want to do to prove that Maui is congruent. Okay, and again, what you should have shown is that this is going to be congruent on both. These are parallel, making this angle and this angle congruent. And then these sides are parallel, making this side and this side congruent. So again, it's ASA. And then the reason that the two side lengths are congruent is because of CPCTC. Congruent parts of congruent triangles are congruent. All right. So this is your classwork for right now. Go ahead and try this. And you also have some extra practice problems. Here's another example of the proof. And then to finish up, you need to finish your packet. There's an extra CUDA practice, and you've got G2 and N4 now on IXL to work on. And any questions you have about your homework, let me know and we can work it out. Or I can give you my answer key.